How to get data into Python from Excel, SQL, Google Sheets, Kaggle. Hello, my name is Sumesh Shukla, and in this particular video, I'll be helping you to understand how we can fetch data from various platforms into Python. We'll be also talking about some basic Pandas operation. But before we start this video, don't forget to check out Scalar's free masterclass on Scalar's event page by leading industry experts. The link is in the description box. In this particular video, we'll be talking about how we can connect various platforms with Python to fetch the data. Also, we'll be talking about various basic operations in Pandas like adding a new column, how we can rename a column, and various other operations. Before we start this video, don't forget to subscribe to our Scalars YouTube channel. Let's understand how to get data from a CSV file into Pandas DataFrame. So first of all, what we will do, we will import the library pandas as PD, and if you want more details regarding the basic of pandas, we have already created a video on this, so you can refer to that video. Now what we have to do, we have to read the CSV file, and the function read underscore CSV takes input as the location of the file. As you guys can see, I have placed my CSV file, which is titanic.csv, in the same folder in which I am running my Jupyter notebook. Now, if you have the CSV file in the same folder where your Jupyter notebook is running, you don't need to provide the exact path. All you have to do is just write the name of the file with the extension, that is titanic.csv, and you are done. Okay, so that is not df.read underscore csv, that is pd.read underscore csv, because pd is the library pandas. So here you can see that we have the data. We will preserve this data in the variable df, which is data frame, and now we can check the head. But what if this particular file is not available in the same folder? So let me just quickly do one thing. I'll go to the same folder where I'm having my Titanic file, and then I will copy it somewhere else also. So over here in the folder Scalar, I'm having this file. I'll copy this, and now I'll go to desktop and I'll paste it over here. Over here I'm having the Titanic file. Now how we can read this file into Pandas DataFrame? First of all, we need the location of this file. So I'll go to properties, and here you have the location. I'll copy this and I'll close this, and now we write pd.read underscore csv, and we will paste this location. Together with this location, we also have to provide the file name with the extension. So titanic.csv. Now if I try to run this, I'll get error. Now this error is because of a very simple problem. The problem is, actually this is not the problem, this is one of the functionality of Pandas or maybe Python. In Python, if I say print Sumit/n Shukla, you will find out that due to this /n, the characters or maybe the string that is after this /n is getting printed in the next line. So this is basically the new line character, and that is what is happening over here. This / character is considered as an special character in Python. So due to this, in this particular string where we have defined the path of the file, this / character is not getting considered as separator but as a special character. So what we have to do, we have to make this string as raw string. If I want to make a particular string as raw string, I only have to put this r in front of the string. So once you put this r in front of a particular string, this string is now considered as a raw string, and all these special characters or maybe the special operators that you have in this string which act differently are now getting considered as characters only. And that is what we are going to do over here. I'll just put R and we are done. Another thing that you can do is you can make this slash as double slash. So I can add one more slash and this will be finally done over here. Now, what if I have to read the data from any other external source? Please remember, your pandas read_csv command takes input from your local system. Also, it can load the file from online repository also. So there is a online repository known as data.word, and here you will find out that you have, the platform looks something like this. Basically, it is an online repository which comes with a huge repository of open source data. But there is one limitation, that is you have to create your account. And once you have the account, then you can simply copy the link and paste it over here and use this data, whatsoever data you wanted to use from this platform, into this local system or maybe your local Python notebook. So I'll go to sign in and I'll quickly create one new account. Sign in with Google and let's say Sumit Shukla. I'll continue and now we are ready. I'll search for the Titanic data and here we have the Titanic data. This is not the best one. So Titanic, I'll search for the one which is having the original Titanic data. This one looks nice. I'll click on download. I'll click on share URL and here you will find out the URL that you can simply copy, paste it over here and you are done. So here what is happening, my data is getting downloaded from this particular link, which is the online repository where we have kept the data, and df.head we have the data. Now let's try to understand how we can perform filter operation on a data frame. If I wanted to filter the data, the very first thing that we have to understand is how to first of all index a column. So as we have learned that if I have to index a column, I can say df square bracket and the name of the column. Let's say I'm using the column sex. So here I'm having the values male and female. Now if I say a is equal to 12 and if I say a is equal to 12, I'll get the boolean output true. Similarly, if I here say a is equal to male, then I'll be able to get a boolean series. Wherever I'm having male, I'll get a true, while wherever I'm having female, I'll get a false. Now I'll use this boolean series to filter my complete table or my complete data frame. So if you guys carefully observe, here I'm having, so this is my condition which will return me boolean series which is true false, and here we are using this boolean series to index my data frame df. If I execute this, you can see that we only have those rows where I'm having the sex as male. Similarly, if I have to apply multiple filters, now I'll quickly go to my presentation and I'll try to explain the normal formula or maybe the normal code structure. So let's say I'm having this kind of data frame where I'm having, let's say, passenger ID followed by sex and followed by the column, let's say, fare. This is my data that I'm having right now. Now this data frame is having values like male, female, male, female. Fare is like 10, 12, 15, 5. Now if I have to filter on one condition, it will be data frame square bracket condition. This is the general code block to write one filter. But if I have multiple filters or multiple conditions, multi-condition, then it will look something like this. df square bracket round bracket condition 1 and round bracket condition 2 and round bracket condition 3 and so on, and close the bracket. So if I have to declare and, we use one time ampersand. For or, we use the pipe operator. Let's say I have to filter this data frame df on male. So I'll just simply say df square bracket the condition df sex is equal to m. This is my condition. Now here in this particular code, these round brackets are optional. Even if I don't use them, that's not a problem. But for writing a filter with multiple conditions, square brackets are very compulsory. df square bracket condition 1 is, let's say I have to find out all females. So sex is equal to f, and here I need to use is equal to f round bracket close, and second condition is df fare is, let's say, greater than 10. So here if you closely observe, I'll just use a different color. These round brackets are compulsory. That's one of the thing. And this is my condition 1. This is my condition number 2. And we have these outer brackets, that is for indexing my data frame df. So that is how we filter a particular data frame on multiple conditions. Let's quickly go back to our Jupyter notebook and let's see one demonstration. So let's say I want all the females with the fare greater than, let's say, $50. So df round brackets df sex is equal to female and df fare is greater than 50. Let's execute this. And here you can see we have the data. What if I want the count? I'll just simply say shape and you will get the number of rows and columns. And if you want the count, you have to first of all index one additional column. So let's say I index passenger ID. And now I'll say dot count. And here we are done. We have 87 such passengers. Now let's try to understand how to add or delete a particular column in the given data frame. So let's say I wanted to add a new column in such a way that wherever I'm having embarked, or let's take an easy example first of all. So I wanted to create a new column, let's say double price. this is the name of my new column, which is equal to the current fare multiplied by 2. That's how easy it is. We have the value, this particular operation, which is df fare into 2, will generate a series with new values. Over here you can see. Now we wanted to preserve this series in a new column which is named as double fare, and if I execute it, if I go back and check df.head, here we have the double fare. But what if I have a condition? What if I wanted to apply a condition, and based on the condition I wanted to generate a new column? Now the method is to first of all create a function. Let's create a function that can take the input, which is the embarked, the category of embarked, and then based on the category it assigns a number. So let's first of all check how many categories are there in embarked. So df embarked dot value underscore counts. Here we have 3 categories SCQ. Now if I want to write a function, I'll say def, the function name is mem, it will take x as the input, and I'll write the condition if x is equal to s, then I want this function to return, let's say 1. Elif x is equal to c, then I want this function to return 2. Else I want this function to return let's say 1 or 0 or maybe 3. But there is one problem. We have to make sure that the embarked column is not having any missings. So let's quickly check that, and I believe that embarked column is having missing. Embarked dot is na dot sum, and here we have 2 missings. So in order to make sure that for missings also we are not getting 3, let's write one additional elif statement. So elif x is equal to a, then write, sorry, it's q, not a, q, then return I want 3, else I want 0. Now I wanted to apply this function to the column embarked. So I'll take the column embarked and I'll say dot apply. So if I wanted to apply a function, the particular method is apply and then the function name em. And now here you can see we are getting 1, 2, 3. We wanted to preserve this in a new column. So df, let's say em b, em binary or em category. And here we have the output. So let's check the data frame df.head, and now I should get the new column emc, which is over here. But if you wanted to use a lambda function, that is also great. If you do not wanted to use the def functionality, so how we can use that? Df embarked dot apply, and the way we write lambda function is lambda input x. I need the output 1 if x is equal to s. Then else I'll initiate another if block. I need 2 if x is equal to c. Else I'll initiate another if block. I need 3 if x is equal to q. Else I need 0. Let's run it. Again we are getting the same output. Let's preserve it. maybe we have already preserved it, so no need to preserve it again. But I hope you guys are able to understand how to create a new column based on condition using defined function and using lambda function. Now let's come to the third point where we have to understand how to delete a column. If you wanted to delete a column, we may use the functionality known as drop, and the function drop can help you to drop both rows and columns. So let's quickly understand. df.drop. Now the drop function takes the input as index, which is the row number, columns, which is the column name, and you can also use it with axes. Let's see all the ways. First of all, we will try to delete a particular row. So I'll say df.drop index is equal to 3. So I'm saying drop the third row. Here you can see I'm having 0, I'm having 1, but I don't have 3. But remember one thing, this particular drop functionality will return you a new data frame with the particular operation applied. So if I go back and check my data frame df again, it will not be having the same operation. This operation has not been permanently applied to a particular data frame. So how to make sure that this is permanently applied? All you have to do is write in place is equal to true. And now if I check df.head, you will find out that the third row has been permanently dropped. Please make sure that these operations are irreversible. So once you have applied it, you will not be able to get your original data back. So make sure when you are using in place, you are using it when you are 100% sure about it. Now how to drop a column? df drop, instead of writing index, now I will write columns. And now I'll mention the name of the column. Let's say I want to drop this double price column. So double underscore price. So you will find out that the column double price has been dropped. But again, this is not a permanent operation. So in place is equal to true, and we are done. There is one more way in which you can use drop. If I say df.drop 1. Now what is the meaning of this one? Is it a row or is it a column? In order to make sure that Pandas is able to understand that this particular input is a row index, I have to define the axis. So I'll go to Markdown and I'll just write down a note for you guys. Axis is equal to 1 means we are referring to columns, and axis is equal to 0 means we are referring to rows. So here I'll say that this is axis is equal to 0. So I'm saying to my Pandas function drop that drop row number 1, and how Pandas will be able to understand that this 1 is referring to row number 1, because I have written axis is equal to 0, which means row. Here you can see that I do not have row number 1. Similarly, if I wanted to drop a column, df.drop, I'll write the name of a particular column, let's say em underscore or hyphen c, and then I'll say axis is equal to 1, because 1 means I'm interested in dropping a column. And here you can see that I do not have that particular column. I hope you guys are able to understand some basic operation with Pandas library. And here we are going to take example of MySQL database. But if you understand this process, you will be able to connect any kind of database with Python. Here we will be first of all connecting the SQL database, which is MySQL database, with Python, and then we will be loading the content of a table into Pandas DataFrame. So let's understand how we can do this. First of all, we need a particular library known as PyMySQL. So let's install it. And the way we can install it using Jupyter Notebook is you have to put exclamatory mark, then write pip install and MySQL. Now you have to execute it, and this will take around 1 minute of your time, and it is done. So based on your system configuration and your internet speed, it will accordingly take time, but for me it has been done now. Now let's proceed with connecting a SQL database with Python. So here I have a open source server. Now this server is running on this particular host name, where the port is this and the credentials are guest, which is by username, and password is relational. So let's try to establish the connection. My connection, which is the connection variable, MySQL dot connect. I have to input the parameter which is host, and my host name is relational.fit.cvut.cz, followed by the username, so user. Now here my user is guest, followed by the password, and my password is relational. Password is relational. Now we have to mention the name of the database with which you wanted to work. This particular open source MySQL server is having a variety of database available for your practice. And out of all the database that is available to us, we are going to only work with this database, which is named as employee. So let's mention the name of the database, which is db is equal to employee, and let's now execute this. So here there is some problem with, we haven't imported MySQL, so we have just installed it. So let's import MySQL, and let's now run this. Now you can see that we are able to successfully create the connection with the MySQL database, which is this particular database. And now we wanted to write a query that can work on this particular database. So the way we do this is by creating a cursor. Now a cursor is nothing but a object that will help you to perform variety of operations, or maybe it is the interaction between your SQL query or maybe your requirement, and it will transfer your requirement to the SQL database with which you are working. So c.cursor, conn connection dot cursor, and this is the cursor that we have created. Now using this cursor, I will pass my SQL query. So I want to first of all look into variety of tables that this particular database is having. So I'll say c dot execute, and I wanted to execute show tables, this particular query. If I execute this, you will find out that this is returning me the output as 6. Now what is the meaning of this 6? Please remember that whenever you execute a query, your output will be preserved in the variable c, which you have initiated over here in the line number 5. Now if you wanted to look into the output, you have to perform the iterations. You have to iterate through each element of this particular cursor. Please remember, this particular cursor is preserving your data in a form of nested tuples. So let's try to look into the output. For table underscore name in C, print table underscore name. And here you can see that we have various table names, and we have all these table names in a nested tuple. Now we wanted to, let's say, work with departments table. So I wanted to look into all the tables or maybe all the rows of the department. Again, we will create a SQL query. We will execute c.execute select a star from departments semicolon. I'll execute this. Now we have 9. So 9 means we have 9 rows. If I try to fetch all the rows, I'll say all rows is equal to c dot fetch all, and it will fetch all the details in a form of a tuple. Now this is your nested tuple. Now we can convert this into a data frame using pandas. Import pandas as pd, and df is equal to, maybe let's call this as dep, department is equal to pd dot data frame and all rows. Now when we look into dep, this is the data frame, but it is not having columns, which is the column header. Let's assign the column header. Dep dot columns is equal to, the first one is dep id, which is department id, followed by the department name. So dep underscore name and dep, we are done. So this is how we can connect Python with a particular database, and using pandas we can manipulate or maybe we can perform any kind of analysis on the data which we can extract after running a cursor. Now let's try to understand how we can get the data from a Kaggle competition directly into our Google Drive so that we can use that data into Google Collab platform. Now it is a very simple process, and let's try to understand how this works out. So the very first thing that we will do is to create a new folder in the drive of the particular Google account with which you are working. So I'll create a new folder and I'll name this folder as scalar underscore Sumit underscore demo. Please try to make sure that you are not putting any spaces in the folder name, because it sometimes creates the problem. So let's create, and now I will navigate myself into this folder. Now the next thing that we have to do is to quickly go to Kaggle platform, and if you have already not logged in, log into this account. So I'll sign out and I'll quickly log in. So I'll say sign in. I'll say sign in with your Google account, and then we'll go to your profile. Then we will click on this account button, scroll down. You will find out an option which says create new API token. Click on this, and as soon as you click on this, it will download a JSON file. Now this is a unique JSON file. So for each user, for example, since I am the user of this particular account, or I am the owner of this particular account, for each unique Kaggle account, you will have a unique credentials which is preserved in this particular kaggle.json file. Now I'll go back to this Google Drive folder and I'll upload this file. So I'll drag and drop over here. Now the next thing is we will launch a Collab notebook. So let's quickly go to Google Collaboratory. It is completely fine if your Google Collaboratory is not working in the same folder. You can put your Google Collaboratory anywhere in your drive. But since I wanted to make sure that all my content or all my material is in the same folder, I am basically placing my Google Collaboratory on the same folder itself. Let's rename this. I'll call this as scalar demo. And now, first of all, I need to mount. Basically, I need to connect this particular folder with this Google Collab. So I have to basically mount the drive. I'll go to this file option. Right now I'm not connected to any runtime or maybe any server, so it is, you can see over here it is connecting. Once it is connected, click on mount drive. It will ask your permission, so I'll say connect to Google Drive. I'll provide the permission. I'll say this account. So we will click allow because I want to connect this particular folder or maybe Google Drive with my Google Collab. So it is basically mounting, and once successfully mounted, you will find out that I'll get all the content of my drive over here. So let's refresh it, and here you can see drive folder. I'll expand it. I'll go to my drive and I'll go to the same folder which says Scalar Sumit demo. So over here we have the folder, and here you can find out that I'm having the IPython notebook, which is the Google Collab file, and Kaggle.json file, which we have downloaded from the Kaggle platform, which is the my account page. Now I have to create a virtual environment, basically a environment on which I can use this particular credentials to create a secure connection between your Google Collab notebook and the Kaggle account. So how we do that? Let's see. I'll use the library OS, which is operating system, and these lines of code are common for all of you. Like, it is not unique for me. If you are trying it out at your end, you have to do the exact same thing. So let's complete the code. os.environment. I'll create the environment as Kaggle underscore config underscore dir, and over here I'll copy the path of this particular folder, place it over here. Now I'll execute it. So what we have done over here, we have created a virtual environment where we are trying to create a connection between the Kaggle platform and the Google Drive platform, so that we can directly fetch the data from the Kaggle platform or the Kaggle competition into my Google Drive. Now the environment has been created. The next thing that we have to do is to change the present working directory. So right now my present working directory is /content. I have to change it. So I'll say %cd, which is change directory, and then I will again copy the path of this folder, paste it over here, and execute this. Now my current working directory is changed to this particular folder. If you want to cross check, just write pwd, execute it, and you can see that the present working directory is Scalar Sumit demo. Now what next we have to do? I'll go to the particular competition from which I wanted to get the data. Let's go to some random data. Here we have data sets, and let's try to use Bitcoin historical data. I'll go over here, copy API command, copy this. Now go to your Google Collab and put exclamatory mark and paste this particular API command, and now execute this. Now you can see that I was able to download the data. If I go to the same folder and let's quickly refresh this. Okay, you can see that we have a zip file named Bitcoin historical data. But right now the data is zipped and we cannot directly use it. So we have to unzip it. How we can do that? You do not have to download this file, unzip and then upload it. Using certain commands, you can do it keeping the file in the Google Drive itself. Let's do it. So we will use the command !unzip. Now I want to unzip all the files with the extension .zip. So I'll say /*.zip. And once they are unzipped, I wanted to remove them also. So I'll say and rm, which is remove all the files with the extension .zip. Let's run it. And here you can see that this file named bitcoin historical data.zip has been unzipped to create the CSV file. Let's check out over here if we have the file or not. We have to wait a little bit. Let's refresh it. Here you can see that the file is now created. Bit stamp USD. This is a CSV file. If I go to over here, here also we have CSV file. Let's copy the path of this file and let's import pandas. Import pandas as PD. Then data frame is equal to pd.read_CSV, and we will paste this path. Now this seems like a very huge file. That's the reason it is taking time. And now let's check the head. So this is the head of the data frame. Let's check the shape of this file. And that is having a lot of rows actually. So you can see the size of this file. So this is how you can connect your Kaggle platform with your Google Drive to get the data into your Google Collab notebook. So I hope you guys are now clear with both the topics regarding how we can get the data from the Kaggle website or maybe Kaggle competition into your Google Drive, and also how we can connect a particular database with Python. So with this, we come to the end of this video. Like this video, share this video with your friends, and don't forget to hit the bell icon so that you never miss any update from us. I will see you in the next video.